In a context, you'll never be given the z-score. So you need to find the z-score. What value will I look up in the table? Because that table only works, if the average mu is equal to 0 and my standard deviation is equal to 1. Well, in a real situation, that rarely happens, if at all. So we can only use the table if that's true. So we need to do what we call a linear, which moves it just in a straight line, transformation. And what that does, it's just a fancy way for giving a relative position the relative position from mu, the center. In other words, where am I at relative to the center? So in order to find this, it's a little formula, and we'll break down this formula. It's x minus mu over sigma. And if you recall, mu is the mean of the population. Sigma is the standard deviation of the population. And x is the observation. Now it's a single observation. And so what happens here is if I look at the x minus mu, let's break that down, x minus mu, that's just telling me how far is the observation from the center. It's telling me, am I to the right? It would be positive. If I'm to the left, it would be negative. And how far is it? Then what we need to do is we need to divide this by the standard deviations. And what that tells me is, in this distance, how many standard deviations the distance is. The distance doesn't help me. It's the number of standard deviations, and that's what a z-score is. A z-score or a standard score is the number of standard deviations away from the mean. If it's positive 2, it means I'm 2 of the standard deviations above. If it's negative 1, I'm 1 standard deviation below. So let's take a look at an example here, again out of context. Maybe I got a score of 40. If you recall, n means it's a normal distribution, and that's what I need in order to do any of this. And mu is 30, and the standard deviation is 5. So if I take a look at the formula and apply it to this problem, my observation is 40. I'm taking away 30. So I'm a distance of 10 away from the center. But that's not in steps. My step size is 5. So if there is 10 as a distance and my length of my step is 5, if I take and divide by 5, that tells me I'm 2 steps. Remember, this 5 is my step size, and this is how far my distance I need to move. So if my step size is 5, it's going to take me 2 steps. Looking at a picture, what I've done here is, it told me here was 30. I was up at 40, and I took 2 steps to get there. So in other words, we did that linear transformation, made this be 0, and this was 1 step, and here's 2 steps. I make them positive because I'm 2 above. Let's try 25. My distance from 30 is negative 5, meaning I didn't go to the right, I went to the left. My step size is still 5, so I'm 1 step below. I am 1 step below, and that's equal to my z-score. So my z is -1. So this will help us take something in practice and turn it into a situation in which we can work the problem. And that will be in the following lecture.